Okay, so a very warm good morning to everyone. On the behalf of IIT Guwahati SP Student Chapter, I, Chitra Sharma, Officer of the Student Chapter, warmly welcome you all to today's webinar on potentials of marine renewables, R&D efforts, and the role of NIOT. We are delighted to have students, researchers, faculty members, and industrial professions joining with us today. So before we begin, I would like to share a brief introduction about IIT Guwahati. The Indian Institute of Technology Guwahati is one of the India's premier technical institutions. It's ranked 8th in engineering and 10th in research in NIRF 2025 ratings. Established in 1994, the institute has rapidly grown into a leading center of academic excellence and innovation. It is currently ranked 344th globally in QS World University Rankings in this year 2025. IIT Guwahati is widely recognized for its cutting edge research, world class faculty, and strong industry collaborations. I would like to give a small introduction of IIT Guwahati SPE student chapter as well. Our chapter strives to create a vibrant platform that broadens opportunities for students through technical, professional, and community oriented activities. By organizing lectures, workshops, and industrial interactions, the chapter aims to bridge the gap between academic research and real world energy challenges, especially in emerging areas like low carbon technologies and sustainable operations. So, today it's a great pleasure of us to introduce our distinguished speaker for today's event. We are honored to have with us Professor Balaji Ramakrishnan, who currently serves as the Director of National Institute of Ocean Technology, Chennai, under the Ministry of Earth Sciences, Government of India. He is also a professor in IIT Bombay. Professor Ramakrishnan is a leading expert in ocean engineering and marine renewable energy, with extensive experience in translating fundamental research into large-scale technology development and field demonstration projects. Under his leadership, NIOT has played a crucial role in advancing indigenous capabilities in such areas like marine renewable area systems, offshore engineering, and deep sea technologies. Through his dual role in academia and national R&D leadership, he has contributed significantly to research, mentoring, and strategic growth of India's ocean technology ecosystem. Today, we are privileged to learn from his insights on marine renewable energy and the role of ocean technologies in supporting a sustainable and clean energy future. Please join me in warmly welcoming Professor Balaji Ramakrishnan. Sir, please.
All right, thank you for the exhaustive introduction, Chitra. I really appreciate that. And all the students and other participants of this webinar, I must first of all appreciate the efforts of the students organizing this webinar. And when they approached us, we thought we will share the experiences of our R&D efforts as well as experiences of how we are trying our level best to harness the renewables or the renewable energies that we can really tap from the marine environment. But given the opportunity, I would like to walk you through the kind of effort not just only happens in the institute that I am heading right now, but I also would like to touch upon what are the general efforts in this perspective. In this regard, again, I would like to thank the student organizing committee to set up this wonderful webinar, which would be of great interest not only for the students, but also the scientists and other young researchers working in this domain. So the topic of today's webinar is going to be like this. We will explore the potentials of the marine renewable. What are the different options and opportunities, and the R&D efforts of various research as well as academic organizations very quickly. And probably I would like to spend more time on the role of this institute where I am currently serving. National Institute of Ocean Technology has really contributed a lot in exploring the marine renewables for the past more than 3 decades of time. This circular picture with smaller inserts, multiple images, basically gives gambit of NIOT's activities, R&D activities, and it also gives a glimpses of the kind of demonstration that we have done it in the either laboratory level, or probably we are the only institution, to best of our knowledge, capable of actually taking laboratory to the actual field in the open ocean testing conditions. We have done number of field trials in the open ocean environment, and what you see is only a glimpses of our team's effort in the past 3 decades of time. So I'll take the opportunity to explain to you what we do in nutshell about National Institute of Ocean Technology, and also very specifically the various options of marine renewables R&D efforts. Since I have come from IIT Bombay and deputation as director of this institute, I would like to touch upon the academic institutions' efforts towards the marine renewables, and a lot about the role of NIOT. And I'm also going to open the opportunities in which the scientific, not only the scientific community, but also the student generation can actually think of way forward. National Institute of Ocean Technology is established in 1993, precisely speaking in November 1993, as a small, kind of a room in one of the departments of IIT Madras, within the campus of IIT Madras. Then it has grown to occupy a floor of a particular building again in IIT Madras. Then we have come out, and then we have built actually a campus of our own in the middle of the city, Chennai city. And now we have grown to become a multiple, campuses, to have multiple campuses in other locations other than Chennai as well. The mandate was very simple at that point of time, given to NIOT. Then it was Department of Ocean Development. Now it is actually Ministry of Earth Sciences, to develop indigenous technologies to harness living as well as non-living marine resources. The mandate was very simple in plain terms. This was given to NIOT in 1993. The idea is actually to design, develop, demonstrate, and wherever possible, we also would like to deliver the technology to the society as well correctly. We have done quite an amazing R&D effort, and a lot of our technologies already reached the society, and we'll see some of them in this presentation. Apart from the campus in Chennai, which is now kind of a headquarters, we do have campus in Port Blair, Andaman. Now it is called Srivijayapuram in Andaman. And we do have a couple of campuses in Andhra Pradesh, and we are thinking of actually establishing field stations, or maybe the R&D stations, extended arms of NIOT in other maritime states as well. And if you look at our footprints, the efforts of NIOT, we have field deployment throughout the year, measuring the various atmospheric as well as oceanographic parameters in the Bay of Bengal, Arabian Sea, and Indian Ocean. And some of our deployments are also there in the Arctic region, which continuously measure the oceanographic parameters. Indeed, the measurement in the Arctic region is shared amongst the global community working in the climate change and also the climate impact assessments. We also have done a lot of demonstration in the Antarctic. That means from coast to the deep sea and from pole to pole, NIOT has spread its wings in the past 3 decades of time. In the recent times, we classified our team into two different, sector. One is to handle the mission mode projects. The other one is actually to handle the operational mode projects. Having realized the fact that the mission mode projects require not only time-bound deliverables, but also there is some kind of a commitment from the institute to the society. So under mission mode projects, we are implementing the entire deep ocean mission, which is begun in 2021, and it is actually going on even today. And another one upcoming mission, which is called Mission Mausam, where NIOT is also going to play a big role in that. Otherwise, since its inception, NIOT has been successfully doing large number of operational mode projects that includes addressing the need of the energy, need for water, addressing the climate change, including the coastal erosion and mitigation measures, suitable engineering solutions, and monitoring the ocean health through developing indigenous instrumentation, electronics, buoy network, floating buoy network, high frequency radar systems, and marine sensors, and so on. We also have very exciting and interesting research vertical within the campus. A bunch of scientists, team of young as well as senior scientists working on exploring the opportunities in terms of harnessing the marine living resources. We're talking about marine biotechnology here. We do have vessels of our own. I think you would be knowing by this time. You have gone through our web portals. And we are also thinking of actually extending not just R&D, but also the services, the expertise of our campus to do services to the allied departments, ministries, and also at times maritime states. Again, in the recent times, we have focused all our R&D efforts to synchronize and to synergize with the United Nations definition of Sustainable Development Goals. And every single research vertical within the campus is focused towards addressing one or multiple such kind of SDGs, Sustainable Development Goals. To be honest with you, we are really proud and happy to inform you that 11 out of 17 SDG goals have successfully been mapped in all our NIOT's R&D efforts. We don't stop there. We also have ambitious plans of growing further, raising the bar standards by ourselves. And again, just last year, we have asked all our young scientists to come up with novel ideas, ambitious plans through which NIOT can see the Vision 2047 from now. Although there are some ambitious projects that have been documented in this Vision 2047 booklet, which you can download in our website. We strongly believe that they are really doable within this time frame, given the kind of experience as well as expertise this institute has got in the past 3 decades of time. We already started working on conceptualization of some of these objectives set under the Vision 2047 document. And through this, we also would like to evolve as a 4D institution. The 4 Ds are nothing but design, indigenously design, develop, and like I said before, we have the capabilities, wherewithal, and means and infrastructure to demonstrate in the field condition in the open ocean. And we would like to see that it is also being delivered to the society directly. So that's the reason why we would like to call ourselves as the 4D institution: design, develop, demonstrate, and deliver. This you can, of course, download from the internet. I think it is projected under the Vision 2047 document in our website. This is all about the National Institute of Ocean Technology in nutshell. And I would like to take a minute or two maximum to highlight the deep ocean mission that is being entrusted to NIOT, not only to carry out the R&D activities within the institute, but also to implement the entire mission as the implementing agency. The reason why I'm trying to highlight and emphasize that part is that the entire mission is given to NIOT, and then there are some components that we have given as the extramural kind of R&D projects to other academia as well as R&D institutions. And the entire progress of those extramural projects is also monitored by us. There are about 6 verticals. Each vertical has specific set of goals, objectives, and also aims to meet within the time frame being set out under the mission mode. It is launched in 2021 just as a pilot program to demonstrate what are the blue economy potential in the country, and in case if we have identified what are the technologies that are available at our disposal to tap and also to exploit sustainably. The word sustainable is also tagged in each one of our R&D efforts. Every engineering design that we work out, we keep the sustainable part in our mind. We know the value of the existing ecosystem. We know value of the existing environmental system that prevail in the not only the coastal ocean but also in the deep ocean as well, without compromising or making any adverse impact to the existing ecosystem. All our designs have been worked out very sincerely. The different verticals again has some kind of a sub-objectives, and we have been working on a very exciting mission mode project which may be familiar to all of you under the Samudrayan mission. We are developing a human submersible called Matsya 6000 in our campus at the moment. 3 of our own scientists are going to go down to a water depth of 6 kilometers deep using the human submersible that we are designing at the moment. The entire components of this Matsya 6000 are already been designed. Materials have been procured. Some are fabricated by our own team, some due to the time and also the deliverable challenges within the mission mode. We also, the design happens here, and then we also give the fabrication and the within the country. And this Matsya is capable of actually spending 12 hours of scientific mission in the water depth of 6,000 meters. Although the emergency system is designed for 96 hours, we expect the scientific expedition will happen within 12 hours. It has wide range of very unique features that we can proudly call Matsya 6000 is actually standing apart, standing on a pedestal which is very unique, and it has carved out its own space in the global human submersible design. There are some unique features. This has already been highlighted in multiple forums, and maybe you can find it in the internet. There are 10 salient unique features of Matsya 6000 puts itself in a totally different pedestal altogether in the global human submersible design. A large number of electronics, large number of hydraulic systems, large number of control systems, instrumentation, buoyancy management system, human safety system, emergency rescue system, scientific payloads, and also the manipulator to operate and collect samples in the deep ocean. The list goes on and on. There are thousands and thousands of components put together. The Matsya 6000 is actually getting shaped up in our campus. And I really welcome all you students. When you find time, you please do visit our campus to witness the integration of Matsya 6000 happening in this very campus from where now I am addressing. It's also a great opportunity for us to do a great amount of networking and build the capacity within the country through this deep ocean mission, again entrusted to NIOT. More than 140 research and development projects have been given throughout the country to many IITs, NITs. A lot of state universities have come together to assist us in making this deep ocean mission a grand success. And this we see as a great opportunity actually for us to create the capacity within the country in the direction of blue economy. Multiple organizations involved with a close watch of the individual projects by what we call it as the interface PIs, interface principal investigators from NIOT. For every project that is being given as an extramural project, there will always be one interface principal investigator within this campus in NIOT, closely monitoring the progress, hand-holding, knowledge sharing, and also assisting wherever the expertise is beyond the reach of the individual institutions where NIOT can pitch and help them out. That's all about in a nutshell. NIOT has been doing in the past 3 decades of time. And I would like to walk you through the marine renewable subject that is taken for this webinar today. I think you all would be by this time aware of the fact that the resources under the marine environment are aplenty. We can actually produce electricity, what we call it as the renewables, like where we have successfully implemented multiple number of wind turbine on the land, solar energy being tapped in large scale. Similarly, we have plenty of resources in the marine environment that really going to help us in tapping the energy from the marine environment. We're talking about tidal streams. Even the variation of the tides can also be tapped into energy requirements. We have waves. We can actually use the salinity gradient where the river meets open ocean. You have difference in the salt content, salinity content. The gradient can be tapped into energy. We can also think of using the thermal gradient variation in the surface temperature as well as you go down deep in the ocean, the temperature difference. And the offshore wind is also strongly believed as one of the potential renewables which can be tapped even in India. These energies, most of them are not affected by any season, including the offshore wind, which is consistent and throughout the year. And there are times that I think it is going to be even stronger. And all other energies are not really bound by any seasonal variations or bound by any other challenges. These are abundant, aplenty, and relatively green. If you look at the kind of technological development in tapping these marine renewables, I borrowed this picture from European Marine Energy Convention. And it dates back more than 2 decades of time where the technology has matured beyond the laboratory level and being implemented in the actual open ocean condition, either as a pilot scale or as a scaled up version in which the power is produced and even supplied to the grid. And the kind of picture that you are seeing, smaller inserts that you are seeing, are the different technologies to tap either the waves or the currents, or it could be sometimes even the combination of waves and currents together. And of course, also the offshore wind energy too. But it took nearly more than 2 decades of time for each one of these to be tested at length, measuring its performance, see whether it can be really sustainable to be put in use in the long term, and so on. Again, if you look at the level of maturity, each one of this technology to harness the given list of resources, marine renewable resources, each one of these technologies have grown enough to either they call in terms of the technological readiness level with which we can take the measure of the metrics basically gives the measure of how well it can actually suit to the field deployment. Some stay at the laboratory level and some go beyond the laboratory level as a pilot scale, and some even go beyond the pilot and scale up to produce power to the grid and so on. So the maturity level is also kind of an indication that where the next generation or the younger generation can really focus and to see whether there can be any value added information or design can be improved upon so that the technological readiness level can be raised up to be implemented in the reality. As you all again aware of the fact that multiple institutions involved in the research of the marine renewables, when it comes to the reality to develop any site for marine renewable explorations, in a large number of activities involved. It's not really going directly from laboratory to the site in the open ocean environment. There are comprehensive, holistic, and range of studies have to be undertaken, starting from the understanding the characterization of the site conditions, and you need to make the assessment of the resources really available, the potentials of the resources available. And then of course there are some kind of permissions, approval required, plan the site, and you have to mobilize the infrastructure and look at the infrastructure from the mainland, how far it is from the mainland, what are the nearest opportunities, are the available resources with respect to the offshore site condition concern. And the installation also require huge amount of specialized infrastructure. The entire construction operation is going to be happening in the middle of nowhere, where there will be no support, immediate support is available in the middle of the ocean. Then it is essential for us to mobilize all the resources and the highly sophisticated infrastructure to the site for the installation of any technological concept. And it doesn't stop there. The operational and maintenance, the wind down, is also a big challenge, and it has to, of course, undergo all the extreme events. I think, as you again will be aware of the fact, the marine environment is quite challenging, and you have the extreme events like cyclones visiting the coastline, the open ocean environment all the time, and the such kind of extreme events should also be taken into account, not only during the design stage but also during the wind down stage.
Sir,
Yes, please.
I want to ask one thing, sir. Sir, you have mentioned about the salinity gradient, right? So, my question is that how much energy salinity gradient can produce? Means how much amount? Means can we be able to produce like electricity sufficient so that we can replace renewable partners? I just want to know what percentage type.
I think this slide precisely answering your question. I also would like to take all the questions at the end if it is okay with you, so that
Okay, no problem, sir. Okay.
given time is not exceeded. And I also request someone to watch the time. Okay. So
Okay,
there
sir.
is these are the kind of again marine renewable options that we have in the Indian context I'm talking about. And recently one of our sister institutions under the Ministry of Earth Sciences theoretically estimated, I'm talking again, I would like to emphasize that this is only a theoretical estimation. The theoretical estimated potential of the entire marine renewable put together, I'm talking about all the list of the marine renewable energy options on the screen projected right now. Put together, we have nearly some 9.6 lakh terawatts hour per year. This is really massive amount of energy that we are talking about. But if you ask me whether all of this is actually tappable or all of this is actually explorable, the answer straight away is, with the current technology available at our disposal, is no. Well, but But this actually opens up the opportunities for us to work towards in tapping as much as possible. Right now, believe me, to be honest also with you, that even 10% of the theoretical potential that we have estimated, even if the 10% is being tapped, I think that itself is great success in my personal opinion. But this number 9.6 lakh terawatts per hour per year, actually power is split into like this. We have energy from the waves, we have energy from the tidal currents, and we have the energy again from the offshore wind. This wind that I am projecting on the screen is only the offshore wind I'm talking about. The amount of energy that we can actually derive from the ocean thermal energy conversion, and also, as you rightly asked, the salinity gradient as well. I leave this for you to imagine what amount of the energy is available in each of these resources that we are talking about. Again, I would like to reiterate the fact that this is only a theoretical estimation. Theoretical estimation with some coarse resolution validation as well. And to confirm and reinforce this claim, I think we need to really do a comprehensive assessment exercise throughout the country. We need to measure the waves at many locations as possible. We need to capture the currents as many locations possible in the country. I think wind has already been started. We have started actually making some effort to measure consistently, the potential offshore wind energy potential. There are some numbers that also confirms the VOTEC, and again, based on the minimal measurements and theoretical estimation of the salinity gradient is also encouraging. Now, I will leave it to you to observe the graph. The salinity gradient is also not very small to neglect. There are some perennial rivers, as you all be aware. The country has along the east coast as well as west coast. The perennial rivers basically bring the fresh water, and the junctions of this perennial river meets open ocean is the ideal locations where we can actually tap the potentials of the salinity gradient. You have nearly single digit or 0 ppt, the parts per trillion that we are talking about, the salt water content being measured in the scientific community by that. And we also have 30 ppt in the open ocean. Using this gradient, we will be able to produce power. There are some special technology again. Now we are also working towards that, and then the subsequent slides, I will show you where we are standing in terms of tapping this salinity gradient. This is a great opportunity. India being a peninsula country with more than 11,000 kilometers of coastline, put together east coast, west coast, and all the islands, Andaman, Nicobar, and Lakshadweep Islands put together. We have more than 11,000 kilometers of coastline. And very interestingly, the exclusive economic zone, which is the territory every country has full sovereignty to enjoy its resources, natural resources. And in India, we have more than 2 million square kilometers of EEZ. I think that is exactly what marked actually in the green hatch in the left-hand side picture. For your kind information, this 2 million square kilometers of area is comparable with your entire land mass. I'm not saying it is equal, but I think it is really comparable number I'm talking about. Our land mass, the entire subcontinent, India, is of the order of 3+ million square kilometers. And 2 million square kilometers is really a big number for a country which has just 3.8 million square kilometer of the entire land mass. The large potentials of the marine resources in general, not just only the renewables I'm talking about here. The large quantum of the marine resources in this 2 million square kilometers of EEZ is yet to be tapped in large scale. We do have, of course, efforts being made sincerely by the R&D institutions and various maritime states. I think the fullest potential of the entire EEZ zone is yet to be tapped. In addition to that, we do have group of islands on either side of the subcontinent. We have Andaman on the eastern side, and of course Nicobar Islands, and Lakshadweep group of islands. Many of them are actually habited islands, and they are also banking hugely on the, depending on the fossil fuel based energy system, whereas they have been surrounded by the marine environment. We already started working on that. We would like to make them independent of power requirement using the marine renewables available apparently in the vicinity of their territorial limits, and which can be tapped wisely, sustainably through engineering effort and indigenous design. And we already started working on utilizing the marine renewables to cater the energy requirement of these islands. But every marine renewable resource being tapped and also being implemented as actually the fullest potential, it has to undergo some kind of a sequence, and what we call it as the methodology in which we approach, in not only in the academia but also in the R&D institutions. We need to have a thorough and reliable assessment of the individual resources. So when we speak about waves, then we should probably make an assessment of the individual marine resources, where are the locations where we can think of actually implementing wave energy based electricity production and so on. We need to employ multiple resources, like we can use in some cases satellite imageries. In some cases, we also invest in the in situ measurements. And it is not possible really for us to collect the in situ information all along the entire 11,000 kilometers of coastline. It is going to be a mammoth task. So instead, what we do, we deploy some in situ measurement campaigns representatively in the places where we feel that the data can really be taken into further, to use that in situ measurements and in combination with the numerical mathematical computer modelings, which can also give some kind of estimate, and use the in situ measurements to validate, and then we can actually estimate the potential along the coastline. Again, comprehensive efforts are required to make the resources and the potentials to be properly assessed. We have plenty of technological choices. We should work out the trade-off between the cost per unit power production and also the kind of capex as well as the operational expenses that may be required to harness the energy. We should also look at very critically what could be the possible impacts of the technological intervention that we are thinking of tapping the marine renewables in terms of the environmental as well as ecological, and at times it may also be required equally to address the societal impact as well. So all the three factors have to be taken into account right from the beginning, and this assessment has to be straightforward and has to be a comprehensive assessment to see no stones actually unturned, to see that there is no adverse effect on the existing environment and ecosystem. And then we usually think of the implementation in two different stages: as a pilot to test and also demonstrate the functional performance of the technology that we have chosen to harness the marine renewable. And once it is successful, probably it can be scaled up to produce the energy for catering into the grids or the nearby community. Doesn't stop there. We need to employ a proper monitoring system, not just only to understand the functional performance of the technology that we have implemented, but also to understand any impact that it actually leaves behind, so that the reliable design can actually happen in the future as well. There are a number of academic studies through the R&D efforts try to understand the marine energy potential all along the country. thanks to many IITs, NITs, and also state universities and even private institutions. There are multiple R&D institutions also involved in estimation of the marine renewable potential along the country. But these are larger picture and needs a validation when it comes to implementation of any particular marine energy project in any particular place of your interest. For example, the one that you see on the screen, top left, is the kind of tidal range available all along the entire Indian coastline. And there are some locations where we have promising tidal energy based resources are available. One, of course, Gulf of Kutch. The other one is Gulf of Kambat, both on the west coast. And we also have some potential in the Sundarbans on the east coast as well. And these numbers that is projected on the tabular columns are again theoretical estimation. But every effort begins with some amount of theoretical estimation backed up by minimal validation. And then it has to be fine-tuned in the subsequent stage. Unlike the northern latitude and of course the southern latitude with respect to the equator, the tropical regions, which is marked by the dotted line on this picture and also highlighted the vicinity around our country, we are not naturally really gifted. This is the wave energy potential spread in a map across the entire globe. If you look at the wave energy potential of the mid latitudes, the tropical regions, we are not naturally gifted. The red ones, either they are in the northern latitude in Atlantic and Pacifics, or southern latitude in the again the Pacific as well as Atlantic and the Indian Ocean, far below our country. This is a well-known fact. This is the natural system, and the wave energy potentials are really great in some of the northern Atlantic and Pacific regions, and put together Indian Ocean within our vicinity and Arabian Sea and Bay of Bengal, the wave energy potentials are very less as compared to the other areas. This is a well-known fact. Keeping this in our mind, we have also tried to reconfirm and also to see whether we can estimate the wave energy potential within the EEZ of our country. This effort has been done by a bunch of the students at IIT Bombay, and we use some kind of a hindcast data sets of nearly some 4 decades of time, and we try to put together to a map which can give us very quick assessment of what is the quantum of the wave energy potential all along the east and west coast of India. And again, this confirms that these numbers are no way comparable to the northern as well as southern latitudes of the entire global region. On the other hand, we have coast said to be eroding. There are some challenges all along the entire maritime states of the Indian subcontinent. Many of the maritime states, they claim that the coast is actually eroding. So one side we have coastal erosion, and the other side we have less wave energy naturally being gifted to our country. Keeping these two factors in our mind, we have come up with a novel idea of why don't we design a concept of wave energy Kaizen that not only serves as either a coastal protection measure or as a kind of a breakwater for construction of any new fishing as well as commercial harbors, and at the same time can also be put in use to tap the wave energy. The reason being that this novel idea basically increases the wave energy slightly better than what it is actually naturally available along our coastline. The numbers are not so promising just as a wave energy conversion device, but when it put into use as a dual purpose, probably it actually cuts into the economy. Thanks to our students' effort, we also have successfully obtained the patent for this concept. And the benefit is that while we integrate the wave energy Kaizen as part of the breakwater design, probably we not only protect the harbor or for that matter any coastline against erosion, but we will also be able to tap whenever there is a wave energy. Especially, for example, along the west coast, during the monsoon period, June to September, we have high wave activity. And when you have such kind of a dual purpose system, during such kind of monsoon season, we will be able to produce power. Especially during that particular time is the community and the coastal community basically banking on the power supply, and probably we can tap the wave energy during those monsoon period. And the other parts of the year, probably it can serve as the coastal protection or for that matter even the harbor protection and so on. So it offers some kind of a protection for the shoreline or harbors, and it can also help us in harnessing the wave power, and that way there will be some kind of a cost sharing on the dual purposes. So this we have successfully tested in the laboratory. Of course, the idea was only conceived, coined, and then it has been comprehensively tested with a wide range of wave parameters within of course this kind of scale model. The dual purpose wave energy Kaizen was tested in our laboratory at length, and we have some promising results so that it can be thought of implemented in future. We extended the resource assessment to understand what is the tidal energy potential all along the Indian coast. And this time we have taken very specific regions into account in our studies. We focused Gulf of Kutch, Gulf of Kambat, and Andaman Nicobar Islands as the individual zones where the potential can be estimated. And again, we have employed large number of mathematical model studies, computation model studies, 2-dimensional as well as 3-dimensional model studies, to estimate the theoretical potential of the tidal streams. There are some locations in Gulf of Kutch and Gulf of Kambat. The uniqueness of these two Gulf, I think, would be kind of familiar. Probably you might have come across. These two locations are regions where the tidal magnitudes are really high compared to the other parts of our country's coastline. And the tidal magnitude can go as much as like 9 to 10 meters high in every day's. I'm talking about every day's tide in and out. And it also creates a very unique hydrodynamics in this region, that the currents on some locations within the Gulf of Kambat can even shoot up beyond 3 meters per second on a normal day. So we have employed different types of, again, mathematical models, and we have estimated this potential in Gulf of Kutch and Gulf of Kambat, and as well as in the Andaman Nicobar group of islands. The uniqueness of the Andaman group of islands is that there are a number of straits where the two islands are separated by a small ocean ocean stream. The tide, which is a natural phenomena, ups and downs of the water level thanks to the celestial bodies' attraction, sun and moon. Because of the tides try to enter into these kind of straits which are narrow, the currents gush into these regions. I'm talking about it's a natural phenomena and it happens almost every day. And these locations can be thought of tapping these potentials. The currents may be just sufficient enough to cater the local community's electricity demands. And we strongly believe of the fact that we may not be able to, given the natural resources available in the vicinity, we may not be able to supply to the grid, but we may definitely be able to supply to the local community's electricity demand, like an off-grid system, portable, discrete, modular systems can be deployed, produce the electricity, and then maybe that may meet the local requirement. We have plenty of opportunities. The macro tidal range of Gulf of Kutch and Gulf of Khambat, the locations where we have strong currents exist on day-to-day basis, 365 days throughout the year. No season really affects the strong tidal currents in many of these regions. These are the great opportunities where we can think of tapping the resources. But equally comes the challenges which each one of us has to take in our mind while designing any technology to be implemented in these regions. Many of these locations where the strong currents exist are shallow waters. I mean, the water depth is not sufficient enough to deploy large turbines or large scale the strategies, technologies. Still, modular, smaller scales are possible. Locations where we have high turbidity, the suspended sediment concentration is very high in Gulf of Kutch and Gulf of Khambat, and it may affect the performance of the technology that you may be thinking of deploying. And any technology that touches the seabed, thanks to the strong currents and high tidal ranges, there are chances that the seabed material can be scoured a lot, and it may pose not only challenge to the very existence of the technology that you are trying to demonstrate, but it may also pose challenge to the existing ecosystem. So we have to keep all of this in our mind. There are shipping lines, the commercial shipping lines ply. Ocean is shared by many stakeholders, not just only those working in the marine and renewable energies. And we have plenty of oil and gas industry based actually infrastructure deployed. And there are large scale infrastructure is also being built, like ports and tidal barrages being proposed to be built along the coastline. So we have to keep all of this in our mind. Even to understand the potential, the results that I have projected on the screen are based on the computational models. But to validate the computer model based estimation, when we try to go out and do some kind of in-situ field measurements, then the nature really poses huge amount of challenges. There are no handbooks that really tells you how to deploy in such kind of a challenging environment, especially in Gulf of Khambat. NIOT has actually made massive amount of effort to understand the hydrodynamics. And even as a researcher, even we have from IIT Bombay have tried to do some kind of in-situ measurements in challenging regions. They are really astonishing challenges being posed to the efforts. Not only that, many of these locations are actually soft clay and the silt material. So it is going to pose any technology being deployed on the seabed. It is going to pose challenges in terms of the geotechnical conditions concerned. And many of these, again, the zones are also highly sensitive ecological zones, and we need to avoid those sensitive zones for any deployment of marine and renewable energy technologies. And so far we have discussed about the R&D efforts of IIT Bombay. We talked about the novel wave energy conversion Kaizen, as well as the tidal energy potential estimation through computation models. And this slide, I'm going to talk about the NIOT's early stage. In fact, this effort was taken up even before the institute was taken birth. In fact, this effort is the reason why the NIOT institution has actually taken birth. The first wave energy converting system, what we call it is the oscillating water column, Kaizen. It started from IIT Madras, the concept right from the basics. It was actually conceptualized. A large number of laboratory tests was conducted. Then the group of, again, the faculty as well as scientists put together, they have gone into the detailed design of how the system should look like. And they have identified a suitable location where this can be thought of implemented on pilot scale. They involved in the actual construction, and it was successfully commissioned in the place called Birmingham in Kerala, along the west coast of India. You can actually browse a huge number of stories, humongous amount of information from the internet. But this institute actually built on top of the OWC Kaizen effort way back in 1990s, early 90s. Some of the pictures that I show you is are the location where this was successfully demonstrated. And also from the basics, our team has actually put in the effort to draw the schematics, to design, to test it in the laboratory, and we also have involved in the construction. And it is constructed within the Virgin Harbor, and then it is taken out to install in the open ocean environment, and it is stored. This Kaizen, when you actually construct, after construction, in spite of their heavy weight, more than hundreds of tons, they still float. And then we take it to the location where it's supposed to be ballasted and put in place. And this is exactly how it looked like when it was commissioned, and it was functioning and producing electricity for a while. And this being a pilot scale, and the long-term plans were not actually envisaged, and the very purpose of installing this OWC Kaizen in Belgium was just to understand and also to create the capacity within the country to be preparing ourselves for taking up large-scale R&D projects in the field of marine renewables. Continuing to that, NIOT has also demonstrated successfully what we call it as the backward duct buoy concept. Again, starting from the scratch, from the drawing board, it was extensively tested in the computer program through CFD analysis, and there were a number of laboratory experiments were done, and then it was fabricated again on a pilot scale and installed successfully in Chennai off East Coast, and it also produced electricity for a while. Encouraged by the past experience, NIOT team has continuously worked on tapping the wave power or the wave potential. And we know that we cannot really produce huge amount of power that can really be connected to the grid, but whereas we can use as a standalone discrete modular products wherever it is really required all along the coastline. Keeping that in our mind, NIOT has designed, developed, successfully patented a wave-powered navigation buoys. Navigational buoys are nothing but marker buoys used in the commercial as well as the fishery harbors for the ship to find out the way to get in as well as out of the port area. Or we also have some kind of what we call it as the navigation channel. This channel basically marked by these buoys on either side, so that the ship can navigate without getting grounded by the shallow waters. So they get into the port as well as exit the port through the navigation channel. And these navigation channels are marked by the navigation buoys. These buoys have some kind of a lantern. During the night time, if any ship has to navigate into the port or out of the port. So we use some kind of a lights. And these navigation buoys usually bank on the battery power, backed up by some kind of a solar panel. And some of these navigation buoys also equipped with some kind of scientific payloads, what we call it as the scientific sensors, to measure the oceanographic as well as the meteorological parameters. And our team has used the experience that we have gained in the past many years of our R&D efforts, and we have designed this wave-powered navigation buoy, successfully patented. And interestingly, the technology has already been transferred to industries, potential industries, which can actually take it up to the commercial scales. And the technology transfer actually been given to the industries. And using the collaboration of the industry as well as the ports, NIOT has successfully installed 2 different buoys. One, of course, in the Chennai port, and another one is in the Kamarajar port. And in recent times, last year, one buoy being actually deployed in the KPL Kamaraj Port Limited in along the East Coast in July 2025. And this particular navigation buoy produces electricity by itself using the wave power in the vicinity, just by the heaving motion of this buoy. And it produces enough electricity that it not only helps the lantern to be, serving the purpose during the night time, but also it caters enough electricity to the many scientific instruments that we have attached to the navigation buoy, including the meteorological as well as oceanographic, sensors. Not only that, thanks to the vicinity of these two ports in the metropolitan region, we have used the mobile network to transfer the data in real time. All the data that we are talking about, the meteorological as well as oceanographic parameters, can be seen in your mobile thanks to the mobile network, and we can get this in real time in your mobiles. And this is one of the successful the wave energy power utilization in the marine environment, and we have large number of demand from various commercial harbors all along the country now. And I would like to play a small video clip on the right extreme of immediately after the deployment in July 2025 of Yenur, how it looks like. I'm sure you're able to see the video, right?
Yes, sir. We can able to see.
There is no solar power required. I insert in those places, we can keep all other scientific payloads. And we have, of course, the energy being produced through the wave power, this navigation. And our team is also involved in the deployment of this entire thing, because it's your own R&D effort. It is being implemented and in one of the major ports in the country. Of course, thanks to the industry partner involved in that. But then when you see that it's really functioning and serve the purpose, even beyond just as a navigation buoy, you also collect a lot of scientific information which are very crucial again for other modeling purposes and so on. The oceanographic as well as the meteorological parameters. It really gives immense pleasure. And our team had stayed there, captured these videos, and then they really cherishing the moment, the implementation of the wave-powered navigation buoy of NIOT. Our team has also spent quite an amount of time in understanding the efficiency of the tidal current turbines, starting from CFD modeling, and then we have tested it at length again in the laboratory environment. And we have demonstrated one of the interesting tidal current turbines designed by our team in the states of Andaman and Nicobar Islands. Like I said before, there are states which are potential for the tidal energy generation. But then the actual fabrication, even for the pilot scale to demonstrate it in one of the states, it has to be in the port environment. In this particular case, it is the Andaman. In Andaman, it is the Port Blair, the city Port Blair, capital city Port Blair. It is fabricated. The entire the tidal current turbine floating pontoon is actually fabricated in Port Blair, and it is stored many 10 kilometers to the strait where it's supposed to be deployed. I think this is quite common in our line of business, and your actual fabrication or construction will happen in one place, and then the implementation or the installation place will be somewhere else, because most of our demonstration happens in the middle of nowhere, and then the resources are usually constrained in such places, and probably will not be able to do the fabrication or construction in those locations where you are actually implementing. But while doing so, the towing itself is going to give you a huge amount of learning exercise, because in the marine environment, the strong currents, strong waves, strong winds, anything that is being towed, taken into the place of your installation interest along the en routes, you'll face a lot of challenges. And while we design, we keep all of these factors in our taken into account in our design considerations and design basis. Actually, this has been successfully done, starting from the small scale lab test, computation model, small scale lab test, and also prototype, but still in a controlled environment test. And then finally in 2026, this was successfully demonstrated in the McPherson state between the Port Blair and the Rutland. This was successfully demonstrated, producing the electricity using the tidal current streams. Nature has not really given us enough wave opportunity that I think I have mentioned to you in the past. But being in tropics, we are gifted naturally by the thermal gradient. Being in tropics, our surface ocean water basically receives higher sunlight. And as you go down deep into the oceans, the water which you cannot see the sunlight or can't really feel the sunlight is relatively cool. And using these two temperature difference, we can actually think of devising some technology which can actually tap energy. On one side, we are not gifted in terms of wave energy, and the other side, we are actually gifted naturally by the ocean thermal energy. This is the global map of the ocean thermal energy potential, and you can see exactly in the tropical belt, we have more energy than the northern as well as southern latitude, which is quite obvious. As you go up in the northern latitude, the waters are actually relatively cold, and in the tropics, it is actually warm. In any particular location of your interest, if you try to measure the temperature and then you try to plot it against the ocean depth, this is how it looks like in the tropics. The surface water is of the order of, again, depending on the season, anywhere between 25 to 30 degrees. And as you go down, the temperature dips and then it becomes a single digit or maybe very close to zero as you go to the deep, really oceans. The deep ocean temperature not actually influenced by any season, whereas the surface temperature is influenced by summer and winter and other seasons of a particular calendar year. So it actually hovers between 25 to 30 degrees. So using this temperature gradient, where you can actually tap the cold water from water depth more than 500 to 1000 meters, and also take the surface water which is of the order of 25 to 30 degrees. Using the gradient, there are two different technologies through which we can actually produce electricity. One is called, of course, the open cycle. The other one is actually closed cycle. But I wish you go through the information, the detailed information in our website as well as in the internet. These are available in the internet in detail. I'm not going to go into the details of how the functions of the individual technology works, but the two different options can be utilized to tap the temperature gradient that are available at the surface as well as in the deep water. The only engineering challenge is that we will have to bring the deep water, which will be away from your coastline. To reach the 100,000 meters of water depth, if you are actually somewhere along the east coast or west coast, you may have to travel multiple hundreds of kilometers actually to reach that water depth. So the engineering challenge would obviously be how to bring the cold water from such water depths. So this is going to be a different ballgame altogether when you bring the cold water from the deep oceans. So NIOT has taken this challenge and we have gone to the deep oceans, and where we wanted to actually demonstrate the functions and also the advantage of this ocean thermal energy conversion system. So we specially designed a barge, and we kept all these, the technology in which the ocean thermal gradient is converted into electricity also built on top of the barge. It is sailed to the ocean where the 1000 meters of water depth would be available in the vicinity. And we have deployed successfully, and we have produced electricity. And this was actually sometime more than a decade ago. This was successfully, commissioned, demonstrated as a pilot scale, with an aim of actually producing electricity of the order of 1 megawatt in the middle of the nowhere. Of course, the gross power rating was 1 megawatt, but the net power that we produced after taking into account of some amount of energy is actually required for you to pump the water from 1000 meters of water depth. And also there are some other, the plant-based electricity consumption. Put all that together, the net power that we have produced was of the order of 600 kilowatt, which is still a significant quantum of electricity that is produced just based on the ocean thermal gradient. And that particular location, we were able to get the temperature difference of more than 20 degrees compared to the surface as well as the deep ocean water depth. And this barge was very specifically designed, fabricated, towed to the location where it's supposed to be demonstrated and successfully decommissioned of late once after the successful demonstration. Keeping the success of the ocean thermal energy gradient concept demonstration by NIOT, we have taken advantage of the ocean thermal energy gradient based energy production to produce potable water in 9 different islands in Lakshadweep group of islands. You may be wondering why we are going all the way to do this demonstration in Lakshadweep group of islands. There are 2 reasons. One, these islands are purely banking on the monsoon-based rainwater for their drinking water supply. Otherwise, there are no other water supply resources absolutely present in any of the habited islands in the entire group of Lakshadweep islands. And they usually collect the monsoon water in small ponds. These islands are actually in the middle of nowhere. They are detached from each other, away from the mainland. And especially during the monsoon, they collect this water and then keep it for the rest of the entire year. So the island community is basically banking on the the monsoon-based rainwater. And it is not at all sufficient for the entire community as such, not only for the community, but also for throughout the year. This is first reason. The second reason being, these islands have got very specific and unique coastal topography. These islands are built on top of the coral. And if you look at their topography, these islands are like a small mountain pop up in the middle of nowhere. The water depth surrounding these islands are actually running into thousands of meters of water. So it's like almost like a pyramid, or maybe like a small landmass projecting all of a sudden from the seabed, and then those topography is actually now what we see as islands, group of islands. So even to reach 500 or 1000 meters of water depth, one doesn't really have to go far from the coastline. So using the natural advantage of the deep ocean available in the vicinity, and also the demand of the potable water supply for the island community, NIOT has successfully designed a very innovative, novel, first of its kind, low temperature thermal desalination concept in-house. We didn't stop there. We also have involved in the detailed design of these LTTD plants, but we have also involved in the actual implementation of all these plants in 9 different islands in Lakshadweep. Right now, as we speak in the webinar, my dear friends, we produce more than 8 lakh liters per day, every single day in all these islands in Lakshadweep. And that's the only source of drinking water supply for the community as of now. And we use, again, in the LTD plants, LTD is nothing but low temperature thermal desalination. We use the difference in the temperature of water depth of 500 meters, where we get some cold water, and we also use the surface water, which is of the order of 25 to 35 degrees. These islands desalination plants has actually already won a very unique future of being inaugurated by all the top honorable persons of this country. One plant is being inaugurated by our honorable president, and one another by our honorable prime minister, and one another by then honorable vice president as well. Again, using the ocean thermal energy, NIOT is building India's first power producing OTEC plant in Kavaratti, the capital island of group of Lakshadweep Islands. This particular OTEC plant is again on a pilot scale. The plant is aimed to produce electricity. At the same time, it is also aimed to produce another 1 lakh liters of potable water per day. The existing plant at Kavaratti, again designed and implemented by NIOT, is not sufficient to cater drinking water supply. We produce, of course, 1 lakh liter, but we wanted to enhance, develop, and this plant that we are building next to that existing plant is also going to produce electricity on its own. The electricity really required to produce the desalined water to the local community. It is one of its kind. There is absolutely no external electricity is required except during the initial stage for this entire plant to run on its own and also to produce the drinking water supply to the local island community. If it is actually functional, it's going to be functional very soon in this particular year. And if it functions successfully, then this is going to be first of its kind in our country and second only to which was simply implemented in the past. Again, we are not stopping there. We would like to aspire big under the deep ocean mission. One of the verticals, we are actually working on a 10 megawatt actually VOTEC based power, and this is going to be in the offshore environment, and it is also going to produce 5 MLD million liters per day. Basically, we are talking about 5 million liters per day, and potable water also going to be produced. Such kind of a floating offshore systems can be mobilized to any place of your interest, produce electricity as well as supply potable water to the demand of the local community. And we have already started working on the detailed project report, the design of the entire project report, and it is going to be demonstrated on a small scale very soon, which is also in pipeline under the deep ocean mission. The future for NIOT as well as for the academic institution is that we already started working on a pilot scale hydrokinetic energy power producing turbines to be deployed continuously for power production for the local communities' demand in Andaman states. And we also have started working on tapping of the energy from the salinity gradient. One project being given to IIT Bombay, and they already created a blue energy lab. The IIT Bombay project is actually involved in 2 different phases. One is to demonstrate how the salinity gradient can actually produce electricity in the laboratory scale, which is a very small unit. And we also have started working on a small pilot scale power producing unit from the salinity gradient, which will be of the order of 1000 watts. And it is actually going to be built on a mobile platform so that it can be taken up to any place of your interest where the river meets open ocean to get the gradient, and we can actually demonstrate producing electricity. And NIOT has already started working on utilizing the hybrid energy potential. So we now realized fairly that the individual marine renewables put together or combined together, they can really produce enough electricity to make individual islands completely free from any demand of fossil fuel based electricity generation. So we have already started working on combining more than one resources like the offshore wind as well as this floating solar, as well as the other potentials like tidal streams and waves put together, make modular units, so that even the seasonal influenced resources, for example, the wind is actually seasonally influenced resources. The marine wind is very strong during the monsoon time, and during the remaining parts of the year, it is fairly not so great. And at the same time, during monsoon, the solar power is weak, and during the remaining part of the year, the solar energy can be tapped up really well. So combining the complementary nature of these resources, we wanted to go ahead with the hybrid power energy potentials for catering the electricity demands of the islands, specifically the Lakshadweep as well as the Andaman and Nicobar Islands in the years to come. That is all actually from me, and I'll be really happy to take any questions if you have. And the slide contains actually a small insert on your left top extreme. Is basically NIOT's in-house design, and it's a saltwater lantern. Basically, you only need 250 ml of salt water, which can be even scooped out of the open ocean. And once you pour that in, this lantern can really give you light for about 500 hours of time. Not only that, in the recent improvement of the same product, we also have given provision for you to charge your mobiles. This we call it as fondly Roshini saltwater lantern. The technology is actually developed in-house in NIOT, successfully patented, transfer the technology to more than half a dozen of industry partners, and they started already producing this saltwater lantern. Very handy, and it can probably be adding great value for the fishermen who are usually sailing out for their fishing expeditions and stay away from their home in the middle of the ocean for 2 weeks or sometimes even a month. And it can also serve as an emergency lighting system during the cyclone events or any extreme events during the power outages. And we strongly believe that it is going to be having a very direct impact to the society in the coastal communities. And the photograph that I have projected in the first slide as well as this slide is taken by some of our scientists when they sail out, stay away from the mainland, and sometimes they stay in the middle of the ocean for 45 days or even 2 months. And every morning they see the sunrise and sunset, and they capture the beautiful moments, either using their mobile phone, and they'll be in the middle of nowhere. Sometimes our team goes to Indian Ocean. They spend more than a month of their time in collecting the data, doing the technological demonstration activities and surveys and services. And these two pictures were taken by some of our colleagues, and I really would like to give due credit to them. Thank you so much for your patient listening. I'll be more than happy to answer any of your questions. Thank you.
So anyone would like to ask some question or? Okay. Sir, actually, I want to ask you that the main purpose of doing this webinar was about. Sir, am I audible, right?
You are audible. Please go ahead.
Sir. So the main purpose of doing that, because most of our committee teams are from the background of petroleum and chemical, right? So we were studying about that oil exploration part, and we face that in oil exploration, especially if we do the offshore part. So we face more problems like the corrosion part and like fungus and this all. And even in the offshore there are many problems like which we cannot like think, we cannot do it like in a lab. So that's why the idea came that at least we should have an idea of this marine part. And even when I saw the work NIOT is doing, so my question to you is that, sir, if like I want to do something in this field, like I'm a master's student, I have completed a master. So if I want to do my research, how can I proceed in this part?
What is your bachelor's background and master's background, by the way?
In chemical engineering, sir.
Okay. See, there are of course opportunities are available equally for all the engineers, all the scientists to work in the marine environment. The blue economy that I have spelled out very briefly is actually a huge opportunity for countries like ours. When we speak about blue economy, it is not just only the marine environment that I have discussed in this presentation alone. We are talking about fisheries, we are talking about energy, we are talking about water, we are talking about even the marine biotech, where the biological resources can be taken further forward. And I did not cover that in this presentation to tell you. The biological future of the marine environment, what entire humankind knows, is not even an iota of the actual potential. I would say like 0.001% or whatever it is. It can be even smaller than that. So that means the biological resource that we can actually tap from the ocean environment can cater into multiple value-added products in the commercial scale. And it can really cater for the human needs, the human society. We are talking about, these products can even lead to nutraceutical, pharmaceutical, food industry. Okay, I'm not talking about the direct consumption of the marine resources as a food, like the fish and other macro structure I'm talking about. There are a lot of microbes that I'm talking about that may not be seen by the naked eye, is actually converted into actually value-added products by our team. We produced actually using the deep sea marine microbe. We produced actually a product which can be used in the aging cream, or what do you call that, the skin protection and so on. We have already patented this, and we have transferred the technology also to the industry, and they're producing in bulk quantity now. This entire product came out of one single microbe I'm talking about, which you cannot see through naked eye. Okay, you need at least 25,000 or maybe 50,000 x zoom of microscope to see that one microbe I'm talking about. And now you can imagine the blue economy potential. And what we know about the ocean is not even
very less.
Yeah.
And sir, as you have attended the like European conference also, so what is the research gap we are lacking in our marine environment and what they are doing, like what we are not doing right now?
No, I don't see any lacking as such. Maybe it is the natural resources that are available around them makes them to go immediately to tap the marine renewable. For example, from the marine renewable point of view, I'm trying to talk. But like I said in the presentation also, there are some naturally not so gifted, resources that we have, and we are trying to make best out of these, naturally available resources. So there must be some kind of a dedicated effort required for that, and that's exactly what NIOT has been doing in the past 3 decades of time. For example, the thermal energy is not there in many other places. Only the tropical countries are gifted with. Okay, so which we have. Yeah.
So our actually college is doing more focus on the marine desalination part. So in marine desalination part, they are actually taking a prototype of carbon, and they are doing how we can increase the vaporization of the water so that we can get the fresh water. And many are doing on the membrane part also. Another question, last question I want to ask you is that if I want to start a startup on this marine renewable technology, so what is the best chance of becoming it like a practical in India? Means, is there a scope of doing?
Massive scope. In case if you are watching the internet very closely, the underwater autonomous systems have already got a lot of attention. Large number of startups have started working on that. I'm talking about the robotics, underwater robotics. Okay, so if you want to really work on the underwater domain awareness, it is not only for the strategic purposes, but also for the even for the blue economy perspective. You need to know the resources. You need to map the resources. You should actually understand the quantum of resources. For all of this, you need to have massive amount of infrastructure deployed. Again, like I said before in doing the presentation, if you measure the potential in one particular location, does not mean that we can estimate the same number everywhere all along the east and west coast of India. So the dynamics change with respect to time, with respect to space. I mean, even along the entire east coast, what you see in front of the Odisha coastline not necessary to be there in the Andhra Pradesh coastline and Tamil Nadu coastline.
So it's unpredictable.
It is not. I'm not saying unpredictable. It is the dynamic that varies with respect to time and space. So you need to really put a lot of effort in measuring the actual potential. For that, you need latest technology, state of the art information. Underwater robotics actually coming up in a big way. Okay, so we are measuring the ocean health, okay, the water quality parameters, or it could be even the animals that live below the water. If you really wanted to know their health conditions, or maybe even to understand their ecological as well as environmental conditions, you need a lot of automated systems. So people already started working on the underwater autonomous systems, robotics. And the challenge actually working in the underwater domain is that no GPS can really go down. So which means your positioning system is going to be very challenging. How do you know that where my autonomous system is now working on? Number two, the communication. Below the water, it won't work with your HF frequency or RF frequency, or even your mobile network won't work below the water. So communication and navigation is a big challenge under the water. And then unlike the topography, I mean the land-based robotics, the underwater robotics is a totally different ballgame altogether. It is actually challenging because of these two reasons. There are many challenging reasons, but I think these two are very important: navigation as well as the communication. So you need to really work on this. I think there is always room for improvement, and also to to cut the corners and make the product actually more efficiency. And that's the reason why we see a lot of startups actually would like to invest in the underwater autonomous systems as well.
Sir, any one of you like to ask any question so that we can end the webinar?
Yeah, I have a question.
Okay.
Very good afternoon. Thank you so much, sir, for such a nice presentation. Sir, as you told us about the microbes, that these microbes are using for different types of cosmetics and all. So, how can we can connect with the team so that we can get some information about it?
I think these information are available in the internet. Anything that once it is publicized, I think it is also there in terms of journal papers, conference papers. Our website has a lot of links with whom we have actually having this technology, transfer of technology, TOT, what we call it as TOT. Transfer of technology happens usually with industries. Okay, once we develop a technology and then successfully patent and publish and make it really viable to be taken up to the next scale, then we, potential that technology partners comes down to NIOT, and then they sign an MOU, and then they take the technology for a kind of a license fee and also some kind of a cost sharing benefit. And then this information is also available in the internet, in fact.
So, is there any particular group also working in IITs?
You have to be very specific. We work with almost all IITs.
Okay, sir.
We work with IIT Guwahati too. Actually, in fact, a couple of our deep ocean mission projects are being implemented by the IIT Guwahati too.
Okay, sir. Thank you.
Okay, so anyone wants to ask more, or we can stop this. So okay, so as we conclude this webinar, our sincere gratitude is expressed to Professor Balaji Ramakrishnan sir for graciously accepting our invitation and generously sharing their expertise and insight. We also extend our sincere appreciation to all our team members for their effort in ensuring the successful organization of this important event. The IIT Guwahati SP student chapters also thanks all the researchers, scholars, students, faculty members, other SP chapters and industrial professions who have joined us today and contributed to the success of this webinar through their active participation and enthusiasm. With this, on behalf of the entire organizing team, the sessions is officially concluded. Thank you all once again, and we will look forward to your continued support in the future events. Thank you, sir.
Thank you so much for your patience listening. I really enjoyed the presentation and also the conversation at the end of the presentation. I'm really looking forward for any future such kind of collaboration. Thank you.
Okay, so thank you, sir.